All right, we're going to continue our discussion in lesson 2 about the angles in the unit circle, or the angles from the origin. And we're going to be building these circles, and it is called the unit circle. We're going to be using this quite a bit. So today we're just talking about the angle measurements. We're going to start with the quadrant angles just like we did in the last lesson. So if my initial side is here, and I don't go anywhere, I have 0 degrees or 0 radians. If I go up to here, so I've made this angle coming around, then I've gone to 90 degrees, which in radians is pi halves. And if I keep going around even further to this line, the negative x-axis, and I've gone 180 degrees or pi radians. And if I circle around to the bottom line from my initial side all the way to here, then I've gone 270 degrees, which is 3 pi halves radians. And then if I go all the way back around, I have 360 degrees, which we know is 2 pi radians. All right. So pi halves is 90 degrees. Pi is 180 degrees. 3 pi halves is equivalent to 270 degrees. And then 2 pi is 360 degrees. So in this next picture, they want us to split these into smaller sections. So I've still got my 0 and my pi halves and my pi, my 3 pi halves. And so I can tell that what they've done here is split it in half. And so half of 1/2 would be 1/4. So this is going to be pi fourths radians. Or if you want to count the sections, they've got 1, 2, 3, 4 sections from 0 to 1 pi. So each one of it is 1/4. So pi fourths, and then a half, and then another fourth would be 3 pi fourths. And then 4 pi fourths would be 1 pi. So whenever we're doing this, if you will count the sections, then I think it will help you if you're having trouble with these fractions, because this is 1/4. Pi halves is actually 2 pi fourths, 3/4, and pi is 4 pi fourths. 1/4, 2/4, 3/4, 4/4. It's just that this one reduces to pi halves and this one reduces to pi. So if you keep that going around the circle, we've got another 4, so this would be 5 pi fourths. This would be 6 pi fourths, which reduces to 3 pi halves. This will be 7 pi fourths. And then, of course, we have our 8 pi fourths, which reduces to 2 pi. So that will help you whenever you're trying to remember where those are later on, because we're going to be using these measurements on this circle for the remainder of our semester in trigonometry. All right, so let's look at the last circle down here. This one, we've got a few more sections in here. We've got 1, 2, 3, 4, 5, 6 sections between 0 and pi. Right? So each one of them would be 1/6. So this would be 1 pi 6. This one would be 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6, and then 6 pi 6, which is just 1 pi. Now some of these reduce. 1/6 doesn't reduce, but this would reduce to pi over 3. This one we already know reduces to pi over 2. This one to 2 pi over 3. 5/6 doesn't reduce. So we end up with some thirds. We end up with 1/6, 1/3, 1/2, 2/3, 5/6, and 1. Okay, so if we keep it going around the circle, 6 would next would be 7 pi 6, 8 pi 6, 9 pi 6, 10 pi 6, 11 pi 6, and then 12 pi 6, which is 2 pi. So this 8 pi 6 reduces to 4 pi thirds, 9 pi 6 to 3 pi halves, 10 pi 6 to 5 pi thirds, 11 pi 6 doesn't reduce. All right, so if you'll notice, I'm trying to make some conclusions, draw some conclusions here. The ones that are up here at the top, they ended up in thirds. And the ones that are in the same position down here at the bottom, also in thirds. The ones that are in the same positions here, 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 and here, all in sixths. Those kinds of things will help you in memorizing this unit circle. So on the homework, what they're going to ask you to do, they're going to have everything marked off, all overlapping. So this circle will overlap this circle, and they're going to want you to fill in all of the measurements all the way around in both degrees and radians. So let's talk about the degree measurements here. This is 0 to 90 degrees. It's split into 1, 2, 3 pieces. So 90 divided by 3 would be 30 degrees. Pi 6 is 30 degrees. Pi thirds would be 60 degrees. Then we got 90 degrees. And then 30 more, 120, 150, 180, 210, 240, 270, 300, 330, 360. So in 30-degree increments. This circle, we went to 90 degrees would be at the top, so half of that here. Half of 90 would be 45 degrees, 90 degrees, 135 degrees. We already know this one's 180. Just keep adding 45 degrees and you can make your way around this circle. But they're going to overlap this one and this one. So when you're looking at them, be sure you know which one. Your pi fourths, they're going to fall in between. When you overlap, they're going to fall in here. Maybe that'll be helpful. All right. So on the back, we're going to talk just a minute about coterminal angles. Coterminal angles are two angles that end up with the same terminal side. That means they end in the exact same spot. So they have some pictures shown here of some coterminal angles. First of all, we have 30 degrees. That's shown right here in this picture. But we could go all the way around the circle to 360 and then come back to 30 degrees. That's what's represented in this picture right here. 390 degrees is going to end in the exact same place as 30 degrees because what we're doing is spinning around, starting on our initial side, spinning around, full rotation back to that terminal side. So we're really just adding a full circle to it. And we could do the opposite of that as well. We could start on this initial side and go backwards to get to that terminal side. And when I do that, I'm really just subtracting the rotation. So I'm adding a rotation here and subtracting a full rotation here, but both of these angles end in the same place as 30 degrees. So all three of these are called coterminal angles that end in the same place. So we can find those angles by adding a rotation or subtracting a rotation. So down here they want us to find some coterminal angles. So one in the clockwise direction, one in the counterclockwise direction, which means we're just going to add a rotation. So 500 plus 360, and then 500 minus a rotation, minus 360. So 500 degrees, 860 degrees, and 140 degrees, they all end up in the same spot. All right, let's do this other one that is in degrees. So we're going to add a full rotation, so negative 60 plus 360, 300 degrees, negative 60 minus 360, negative 420 degrees. Negative 60, 300, and negative 420 all end in the same place. All right, now then, let's talk about these radian ones. We still want to add a full rotation. A full rotation in radians is 2 pi. So if I want to add this together, these are fractions, so I need a common denominator. So I'm going to do fourths. So pi fourths plus, I'm going to need to multiply this by 4 over 4, so I get 8 pi fourths would equal 9 pi fourths. Or I could subtract a rotation, subtract 2 pi, and it would be pi fourths minus 8 pi fourths, which would give me negative 7 pi fourths. So pi fourths, 9 pi fourths, and negative 7 pi fourths all end in the same place. And the same with this one, negative 2 pi thirds. We can add a full rotation. We're going to need a common denominator, so we're going to multiply by 3. So negative 2 pi thirds plus 6 pi thirds would equal 4 pi thirds. Or negative 2 pi thirds minus a full rotation, so negative 2 pi thirds minus 6 pi thirds would give me negative 8 pi thirds. All right, so this lesson is really about a couple of things: the coterminal angles, that you can find the same terminal side by adding a rotation and subtracting a rotation, and the building of our unit circle, where we're going to overlap these circles and put all of our angle measurements on the same circle.